This session discusses broadcasting in Numpy. Broadcasting allows Numpy to work with arrays of different shapes when performing different arithmetic operations. Usually we have a smaller array and a larger array, and we want to use a smaller array multiple times to perform some operation on the larger array. In that case, we can use broadcasting technique. For example, suppose we want to add a constant vector to each row of a large matrix. So the large matrix is X, and we want to add the constant vector V to the X. So there are different ways of doing that. The usual Python way is using a loop. So using a loop, for each row of the X, we can add V to it and store it in another array. Another way of doing is forming a matrix VV by stacking multiple copies of V vertically, then performing element-wise summation of X and VV. So this can be done like this. We have an array called X, which is of shape 4 by 3. We have a array V, which is a one-dimensional array with 3 elements. So what we will be doing is, we will be stacking this V 4 times, or stack 4 copies of V on top of each other. So that will produce VV like this: 101, 101, 101, 101 4 times. So for that we will be using the tile method. So we will be giving nb.tile b comma 4 comma 1. 4 comma 1 specifies number of copies we need to make. So if you give 4 comma 2, then it will be like this: 2 copies to the right and 4 copies to the bottom. So what we need is 4 1. So we will be giving 4 1. Then this X and VV are of same dimension. After that we will be doing y equal to X plus VV. This can be done without stacking using the broadcasting. So in the case of broadcasting, what we need to do is, we can just type y equal to X plus V. So if you write X plus V, then the array, which is of one dimension with the 3 elements, will be automatically converted to the dimension matching X, and it will be added up. This will be done automatically without making a copy, so that this broadcasting operation is much faster for larger arrays. That is why broadcasting is usually preferred when you are trying to do the operation on larger arrays. It will be considered as one with the size 4 3, and element wise summation is done, since the operation is y equal to X plus V. So in order to do that, you should know how broadcasting works. So broadcasting two arrays together follow these 3 rules. First rule is, if the two arrays differ in their number of dimension, then the shape of the one with the fewer dimension is padded with 1 on its left side. And second rule says that if the shape of the two arrays does not match in any dimension, then the array with the shape equal to 1 in that dimension is stretched to match the other shape. And the rule 3 says that if in any dimension the sizes disagree and neither is equal to 1, then an error is raised. We will see this with the help of an example. So we have two arrays, one with the shape 2 3, and another is a vector which is of size 3 elements. So we are trying to add these two. So So rule 1 says that if two arrays differ in the number of dimension, the shape of the one with the fewer dimension is parted with the one on the left. So this one dimensional vector is parted with the one on the left. So the vector will become one with the shape 1, 3. Still the two shapes are different. So the rule 2 says that if the two arrays does not match in any dimension, then the array with the shape equal to 1 in that dimension is stretched to match the other shape. So we have a 1 here on the left. So it should be stretched to match the other array. In that case, in the other array, the shape is 2, 3. So 1 will become 2. So our matrix with the shape 1, 3 will become 2, 3. So we have two arrays, two matrices of shape 2, 3, which can be added up. We have two arrays. One is of size shape 3, 1 and other is one dimensional array with 3 elements. So based on the rule 1, we will be adding a 1 to the left. So one dimensional array will become 1 with the size 1, 3. And the shape of other matrix is 3, 1 and the current matrix is 1, 3. So based on rule 2, we will be stretching the that 1 to 3. So the shape will become 3, 3 and the operation is done on the resultant matrix. So taking another example, we have a matrix of shape 3, 2 and another matrix, one dimensional matrix, one dimensional array with the size 3 elements. So we will be adding a 1 to the left. So based on the rule 1, shape will become 1, 3. So then the one with the 1 is stretched to match of the other array. So shape will be 3, 3. But after that we can see that the shape of the one matrix is 3, 2 and the shape of other is 3, 3. So based on rule 2, it says that in any dimension, if in any dimension sizes disagree and neither is equal to 1, we can see that neither of them is equal to 1. So we cannot stretch, then an error is raised. So which means that broadcasting cannot work on this. So an error is raised. So this is how it works. So next we will see an example where we are trying to add a vector to each row of a matrix. So using broadcasting, you can write x plus v. In that case, in our case x has shape 2, 3 and v has shape 3. So broadcasting will make v as 2, 3 and x and v are added up. So element wise addition is done. We have a w, which is a one dimensional vector of size 2 and our x is of size 2, 3. So what we need to do is we need to do we need to add vector to each column of x. So idea is we need to reshape w to 2, 1. We can use the reshape method for that and we will be doing broadcasting on that and by typing x plus nb dot reshape of w21. This will make w to match that of x column wise, so that column wise addition is done. So based on our requirement, you can define your own logic to do broadcasting so that desired output is achieved.